As you know that this is going to be DNS, domain name server. Mainly our focus would be to learn about the basics of DNS and then advanced features of the DNS servers that we can deploy on F5 DNS module or Big IP DNS module. So that's the objective. And to look at the content, let me quickly open up the book for this DNS module. So let me show you this. If you look at the content. So obviously, the first chapter is all about setting up the big IP, which we have already done during LTM. So we are not going to cover this chapter one. It's already covered. Chapter two is about the introduction to the DNS. And yes, that is very important for us to understand the function of DNS, domain name server or domain name system. So you must be knowing that everything is running on DNS. Everything, like especially when it comes to internet, it's running on DNS. You know what? The moment you access anything over the internet, let's say you say google.com, or maybe you say f5.com, or you say cisco.com, everything you are accessing, using names. But in background, it's an IP address. But we don't tell our machine that what the IP address for cisco.com is, what the IP address for f5.com is, what the IP address for google.com is. But then my machine identifies that automatically by the help of DNS. To do so, it is mandatory for us to allocate the DNS server IP address. We must be having some DNS server that can resolve names into an IP address. So even if you look at my configuration here, my machine must be having a DNS server. So if you look at the DNS server, this is the DNS server that I am using. It is a public DNS server provided by Google, right? Quad 8. It's a public DNS server. The IP addresses we have got there, and then DNS server is also there. In fact, you can use this NS lookup command, www.google.com. So it would give you the IP address of the www.google.com. Similarly, if you say www.cisco.com, it would give you the IP address for the cisco.com. Not only IPv4, but also it gives you IPv6 address. So based on the infrastructure, whether it is IPv4 infrastructure or IPv6 infrastructure, you would get connectivity with those IP addresses. That is something that you should keep in your mind. Now, before DNS, we had a concept of the host file. We used to keep a host file locally on the machine, and then we used to create the entries manually there. Like we used to create a file where we would provide names and IP address, and we will do that manually. So it was not feasible, especially when you got lot many domains, especially when internet came into the picture, because the internet has got unlimited number of domains. We do not even have the actual numbers. If you have that many names and their corresponding IP addresses, then it was next to impossible, to manage the host files. Question is that how DNS is working. So obviously the DNS server, DNS, like basically in DNS, you have got a client and then you have got a server. So server would be responsible to maintain the database that would maintain the entries for names to IP address. So you have to create the database. So someone will have to create that. But over an internet, then how it is possible? That is where for internet, there is a hierarchy for DNS, because one man army cannot be there. Like just one person cannot create all the DNS entries. Then we have to understand that. Anyways, let's get back to the content. So we have to understand DNS, what is DNS, how it works, then how Big IP can help to accelerate the DNS resolution. So here we will take the help from Big IP for accelerating the DNS resolution. The next chapter is chapter 4, that is to implement the intelligent DNS resolution, because this is the only reason that we use Big IP for DNS functionality. This is the only purpose of using Big IP as a DNS, because Big IP gives you an option for intelligent DNS resolution. Right. For an example, I can give you a couple of examples. You can tell your Big IP that, hey, if we have got multiple data centers, right, across the regions, and then after I want to create a policy that if clients are coming from US, then they should get an IP address of the US data center. If the clients are coming from European Union, then they should get the IP address of the Europe data center. If clients are coming from India, then they all should get the IP address of the Indian data center, So that way, like based on geolocations, we can tell our Big IP to perform the DNS resolution. And that is one of its kind of feature. And then monitoring on top of it. Big IP can also monitor your backend application servers before providing those IP addresses in response to the DNS requests. So that is another advantage of big IP, and that's what makes it intelligent. Now, to implement intelligent DNS resolution, obviously we have to configure data centers. Then we have to configure the virtual big IP LTMs, big IP DNS, iQuery communication between big IP DNS and big IP LTM. You can also add non F5 servers, then create wide IPs, create pool, and also configure LDNS props and collect the metrics in order to take the intelligent decisions. Like you can also perform the DNS resolution based on the hop count. Like you should, we can tell big IP to provide DNS responses based on that how many hop away the application server is from the client. For that, you will have to collect the props and metrics. And then load balancing. Just like on LTMs, we had different types of load balancing algorithms. In similar way, we have got different types of load balancing algorithms in DNS also. So we will see that what is round robin ratio, global availability, static persist, RTT, round trip time can also be used, completion rate, CPU utilization, number of hops, least connection, so and so. So we will be learning about those load balancing algorithms. Although in production environment, we mainly prefer to use round robin type of load balancing algorithm. But apart from that, we use static persist and also we use global availability a lot. So we will see some of these load balancing algorithms, that how do they work and all that. And persistence is there. Then monitoring, like how we can monitor the resources. Like if I have to monitor the application server, whether it is really available, it is reachable. So how we gonna do that? And we have got last topic, last chapter, chapter 8, that is to implement DNS security. Like how do you ensure that DNS response is coming from the legitimate DNS server? For an example, if I am performing the DNS resolution, how can I validate that yes, this response came from a legitimate server? So that is very important to implement the DNS security. Sometimes, not everywhere, but sometimes we implement that DNS security. And also you have got a sync group, like in LTM, we configured the HA group for high availability. But in regards with the DNS, we don't configure high availability, like active standby, something like that. No, we don't do that. We always implement active type of sync group. We have to use both of the DNS servers. Let's say you have got two data centers and you have got one DNS server in each data center. So between those two DNS servers, we just create a sync group, so that if you create any object on one of the DNS server, then it gets created on another DNS server. It's the whole purpose of creating sync group. But we don't do any kind of failover in case of the DNS. So that's that. So that's it. That's all you had there. So that's what we're gonna cover throughout this training. So it's not going to take that much long time to cover all of these topics. It's just that you need to understand the DNS first. The first objective of this training is going to, to learn about the DNS, like what is DNS. And as I gave you an example, that DNS is a very critical component, especially with in regards with internet, because if you are accessing any object over the internet, you must have observed that we don't access anything using IP address. We are accessing everything nowadays using names only. And you know that in networking, you can't access any resource without IP. So at one hand, we are saying that we can't access anything without IP. And at other hand, we are accessing everything using names. So how is it happening? How is it? So that is very crucial for us to understand. So evolution of DNS, as I told you, like first we started with the host file. So even your machines, like if my laptop, if I talk about the host file, so this is how it looks like. So on your machine, you just go ahead and update this host file, put the IP address and then its name. That type of host file was needed to be created for each machine. But as I told you, as internet started growing up, people started using internet, because that was an evolution at its peak. Because before that, there was nothing like sort of live connectivity. But then internet brought the revolution in infrastructure technology in IT field. So that is where this DNS came into the picture. And you must be knowing that DNS is a open source protocol, open standard that you must be aware of. And with DNS, we have got a hierarchy, like root DNS, then TLDs, top level domains, then we have got subdomains. So like dot is a root domain. And the root servers are managed by some of the entities in US only. So if you look at the list of root servers, list of DNS root servers, look at this. So there are 13 root servers a.root-server.net, which is operated by VeriSign Inc. And this another root server is operated by University of Southern California. C.root servers.net is maintained by Cogent Communication. And this another root server is maintained by University of Maryland. This another root server is maintained by NASA. Another root server is maintained by Internet Systems Consortium Inc. And then US Department of Defense, US Army, then NetNod, again VeriSign, then RIPE, ICANN, and Wide Project. There are total 13 root servers maintained by different organizations. What these root servers does is that they maintain the first level of domain or top level domains. These all are the top level domain servers. So their database is maintained by root server. What is IP address of .com? What is IP address of .edu? What is the IP address of .org, .in, .usa, .us, .com, .gov? So all that database is maintained by root servers. And then each TLD like .com, then .com would maintain the furthermore database like F5.com, Cisco.com. What are their IP addresses? TLD would maintain all that database. And then within F5.com, you can also have like another subdomains such as tech.fi.com, hr.fi.com, sales.fi.com, and then within tech.fi.com, you can also have users like Fred. So fred.tech.fi.com, like that. So that is FQDN, fully qualified domain name. But remember that we as an end user, we do not maintain these root servers. Also, we do not maintain the TLDs. Yes, we can maintain the authoritative server. Let's say imedita.com. So I can maintain my own DNS server. So I can maintain my authoritative DNS server. So I can build my own DNS server for this domain imedita.com. But I'll have to pay some money to the TLD, top level domains. I have to tell you need to create imedita.com entry, and this is the IP address. So I need to tell them the IP address of the authoritative DNS server that is maintained by us, by me. We use non-authoritative servers as well, where, let's say to create this imedita.com, I don't want to host my own DNS server. Instead, I want to purchase DNS services from the third party like GoDaddy, Amazon, or maybe from the Microsoft or whatever, or whichever vendor you want to use. They can configure the non-authoritative DNS servers on your behalf, and they can create an entry for you. Like if I try to identify the IP address of the imedita.com, and let's look up www.imedita.com. So you would get the IP address here, the list of IPs that are being used here. So it is very important for all of you to understand the DNS function. You must be knowing that DNS uses UDP for any communication that takes place between client and the server. But if there is any communication taking place between one DNS server to another DNS server, then it uses TCP. But port number remains same, that is 53. For normal name query between client and server, it will use UDP port number 53. Whereas if anything happening between DNS servers, then it will use TCP. Like for an example, if you look at this, the communication is happening between client and the local DNS first, LDNS. So this communication would happen using UDP. But then if local DNS is talking to your root server or talking to TLD or talking to your authoritative name server, then over there it will use TCP by default. But port number would remain same, 53. So between client and DNS server, local DNS, it is always going to be UDP port number 53. Because you know what? Your client would keep on sending DNS request to the local DNS until it gets resolved. It does automatically. You don't. So if you're sending some information periodically, then you don't need to use TCP for sending those packets. You don't need TCP. But here between servers, you don't send information periodically. It is important to send whatever you are sending with reliability. So that is where the TCP was needed in this case, in this scenario. So yes, TCP will be used there. Questions? No? Fine. Now I would ask you both to just, because this guide is already uploaded on your portal. So just go through it and read about the DNS only. Just DNS. How it is taking place. Like here you could see, it's clearly explained here that first you sent your request to local DNS. If local DNS doesn't have any answer, then it can go to root. From root, it will get the IP address of TLD. Now from TLD, it will get the IP address of the name server itself. And then you go to name server. The name server will provide you a response back. And that's how you get connected with that IP address. But then after this client PC and your local DNS would create those entries in their cache also, in their DNS cache. So next time, if you're trying to access the same domain, you don't really have to follow the same steps. Why? Because client would find the IP address of the f5.com in its DNS cache automatically. That's the advantage here. Any questions, Abdu, or maybe Kamal?
No, fine, fine.
All right. So if you can just go through this process once by your own, it would be great. And local DNS is nothing, is my local DNS. Like even at your home, your modem must be working as a local DNS. So as I told you, this is root. Dot is just root, and .edu, .com, .org, those are TLDs, top level domains. And then you have got subdomains like f5.com, oracle.com, cisco.coms. And furthermore, within f5.com, you can again have subdomains. So that's something that you should always keep in your mind. So now you're not having all the entries on a single server. So it's a kind of distributed architecture, distributed database. So root servers would have only TLDs, and TLDs would have only your name servers. And you have got different TLDs for each domain, like .edu, you have different TLD. For .com, you have different TLD server. So it's a distributed database basically. For today, I'll keep it short. Tomorrow, I'll simply start with some of the deployment. Try to access the topology. Let me show you the topology quickly. Let me close this. So I have a different topology for the DNS, also known as, earlier we used to call it GTM, Global Traffic Manager. So this is the topology. So I've got a big IP DNS somewhere here, and then I have got two different data centers with LTM. One is here, the other one is here, and then I'll be using this big IP DNS in order to perform kind of load balancing based on the DNS resolution. Right, so we will see that. So tomorrow I'll bring up this big IP DNS, and I also have got the backend DNS servers here in this topology. So first I'll use this big IP DNS just to perform load balancing among these backend servers. But that is something that LTM also could do. So then why are we placing the big IP DNS there? Because LTM can also perform load balancing. So that is where we will see that how we can improve the DNS resolution process, how we can make faster DNS resolutions by the help of big IP DNS. That is where it will come into the picture. But anyways, this is the topology that I'll be using. And this is my client that would try to access the resources hosted in your both of the data centers using names, not IP, but using name. And that name would be translated into an IP address by this big IP DNS. So that is where the name resolution will take place. So basically, there are three big IPs in this topology. One is acting as a DNS here, and then we have got this LTM, and this is another LTM in another DC. So we have got these two different big IPs out there. So we'll continue this tomorrow. If anybody has any questions, do let me know. If not, then let's meet tomorrow at same time. I mean, I'm asking you, are you comfortable with the way DNS server works? So let me show you one DNS server. So I have a AD server. Let me also log in onto that machine. Kind of the AD server. But also it is working as a DNS server. So let me open that up. This is your DNS server, and it has a forward lookup zone, which translates your names into an IP address. So this is the domain name, testumbrella.com. Within that domain, I've created all these entries like I01, ICE1, ICE2, LTM1. We can also create like other entries as well, like host A entry. Let's say saurabh.testumbrella.com should have an IP address called 201.100.100.50 like that, an add host. So this is how we can create the entries like this, and we can keep on creating those entries. So that's how we build the database on DNS servers. And let's assume that for my machine, if this server is acting as a DNS server. So if I'm sending any DNS request to this DNS server, so obviously it will check its cache and also its database like this to see if it has got the entry for that name for which I have sent a DNS request. If not, then you would also see that if you go to properties here, that it has got the root hints. Do you get it now? That it has got the root servers, the list of the root servers. So this server can directly, either it will forward it to the forwarders if it has got a forwarder, which it has actually. So if it doesn't have any answer for my query, It will forward those requests over to the forwarder. If forwarders are not there, let's assume that I do not have forwarders, then use root hints, which means root servers. You get my point, Kamal? That I'm sending a DNS query to this DNS server. It will try to resolve my DNS query by using either its database like this or its cache. So what I'm saying is the moment your client is sending a DNS request to your DNS server, it will check if it has got the entry in its database like this or in
Yes.
its, if the entry is not available there, then it will see if I have got a forwarder. So if you go to the properties of this server, then if you go to forwarders, so I've got these two forwarders. But at same time, you should also know about it that if forwarders are not there, then use root servers. And my server, my DNS server already knows that who are the root servers. Yesterday we saw that list, if you remember.
Yes.
Yesterday, we saw the list of the root servers, and that
Yes.
information is already there on my DNS server. So imagine if you do not have the forwarders available on my DNS server, on this Windows DNS server, then first it will go to your root server. From root server, it will get the IP address of the TLD. Because sometimes
Yes.
you would send a DNS query for, let's say, google.com. So .com is a TLD, top level domain. So from root, it will try to obtain an IP address of the .com TLD server. So root will tell about the TLD IP address, and then my DNS server, this DNS server will go to the TLD, top level domain server. And from there, it will get the IP address of the name server, whether it is authoritative or not authoritative, but it will get the IP address from there. And then it will go to that name server to resolve the actual query. And when actually resolution takes place, this server is also, I mean, this is local DNS, by the way. I'm assuming
Okay.
that this Windows
Yes.
DNS server is your local DNS. Make sense?
Local DNS. Yes.
Okay. Good. So this is what I also explained yesterday. Yesterday I just explained it using drawing, but today I have just done it using a DNS server itself. So that you could see that yes, my Windows DNS server is also maintaining a list of root servers, and that is how it reach out to the root servers in case if it doesn't have any answer for the query. So, and remember, between my client and my local DNS, the communication would happen using UDP port 53. This is weird. Why is it stuck here? We do not have any other option other than waiting. Come on, let me refresh this page now. I have to reperform this initial setup. Something went wrong last time. So, these fields like with blue borderline, that is mandatory field. So if you don't put any value there, then you can't really proceed further. And without completing this initial setup, like now I'll have to click on finished. So now only I'll be able to see all the options to configure the DNS. So now you could see that DNS option is there. And this is not important. GSLP is more important. That is global server load balancing. So this time you don't see local traffic. Do you see local traffic option available for yourself? No. And that is expected because we did not configure the local traffic. We did not provision that module. So we are unable to see that. But other than that, everything else is same, like the system. And then if you talk about network, it's all same. So I'll go to network now and then VLANs. So I have to create two VLANs. Let's create external VLAN for 1.1 and then internal VLAN for 1.2. So create one VLAN here. So this is internal VLAN, which is VLAN 10, let's say. And the interface is 1.2. So that's 1.2 and then keep it untagged, because I'm using access port. I'm not using a trunk port there. If it was a trunk port, then I must have tagged it. And then repeat, then say external VLAN, that is VLAN 20 in this case. Interface is 1.1 and tag, add it, then click finished. So I've created those two VLANs. It's time to set up self IPs, create. So this is external IP. Based on diagram, it must be 12.1.2. So the IP address is 12.1.2. Subnet mask is 255/24 external VLAN. Then we can say allow default. But also you could keep it allow none, which is the default one. It's a non-floating IP, which is great. And then repeat this. And then internal IP, right? Internal IP. The IP address is going to be as per the diagram 50.1, 192.168.50.1. Then internal VLAN, allow none or maybe allow default, you could say that. And then finish this now. And then add a default route as well towards the internet. So this is default, is a static default, by the way. Destination is 000. Mask is 000. And then gateway is like gateway is 12.1.1.1 like that only, 12.1 and finished. So we have got the default route, by the way. And now since the IP addressing is set up, so I'll take the CLI access here. I will try to ping some of the IP addresses, especially my backend servers, which are 50.10 and then 50.20. That is also not reachable. So my IP was supposed to be 50.1. So yes, 50.1. Okay, VLAN is incorrect. VLAN was supposed to be internal VLAN. The moment you change that, you should have reachability to your servers. 50.10, yes, it's reachable, which is great. And then 50.20, that is also reachable, which is great. And from here, I should also try to reach, 12.1.1. So that IP address is also reachable. So if you have got any other questions here, then fine. Otherwise, we have done this basic configuration here, especially, IP connectivity and all that. Then, you know what? I've got these two backend DNS servers here. Let me try to access them one by one. So this is Windows DNS server in my topology. It's pre-configured. This is Windows DNS server 1. It's pre-configured, by the way. I would like to open up the DNS settings so that you could directly see that what I have done there. So under forward lookup zone for imedita.com, so that's a domain. I've created like hr.imedita.com entry, id.imedita.com entry, and I've created like those double IP addresses. So it seems like maybe that hr.imedita.com is hosted using these two IP addresses, 661, 551. Then it.imedita.com is hosted using these two IP addresses, 662, 552. And saurabh.imedita.com is hosted over 555.2. And then www.imedita.com is hosted using two different IPs, quad 5 and quad 6. And the same database should be available on Windows DNS Server 2. Same entries are here. Now, point is that I cannot use those DNS servers for my internet user. I cannot. My backend Windows DNS servers are having private IPs, so I cannot use them. So I'll do one thing. I've got a public IP pool, which is quad 777.0/24. So that IP pool belongs to my organization. So I need to pick one of the IP address on my BIG-IP DNS. I would use BIG-IP DNS as a LTM for now. I would like to load balance my DNS request, like whichever DNS request my BIG-IP DNS is listening or is receiving should be distributed among these two servers. So this is how I want to configure this BIG-IP DNS initially. For that, I'll have to add nodes. I'll have to create pool, and then similar to virtual server on LTM, I'll have to create a listener on my BIG-IP DNS. So on BIG-IP DNS, I don't call it virtual server. We call it listener in terms of DNS. So I'll do one thing. I will first go to DNS and then delivery. Under delivery, I have a load balancing option and then nodes. So look at that delivery, load balancing, nodes, and then add those nodes. So create, this is DNS server 1, whose IP address is 192.168.50.10. Repeat, DNS server 2, 192.168.50.20. Then delivery, load balancing, nodes are there. Go for the pools, create the pool name. This is DNS server pool. So for now, I'm just using gateway ICMP, but I could also create a DNS based monitor. I will also cover that. Then node list, we already have a node list. So DNS server 1, word port 53. So it should be 53. So just type in 53 if it is not available in the list. Add, and then server 2, add. So I've added both of the servers and then get this finished. And you could also do one thing. You could also create like by going to delivery, and then you have load balancing and then monitors. So you could also create a monitor, DNS monitor, and then select DNS there, and then type a query name www.imedita.com. And receive string is like quad 5. I'll also get quad 6, but quad 5 is also there, right? And then get this finished. And then I can go back to my load balancing and then pool which we created. Then I can also change its monitor, and then we can make it DNS monitor. So as long as we are getting that response from there, we are all good. See, so we are sending DNS query in every 5 seconds. We can also see that in captures, like capture on 1/2, 1.2 interface. So you would see that we are sending a DNS query in every 5 seconds. And that is www.imedita.com. So I'm sending a DNS query from .1. So let me open this up, DNS query, queries w.imedita.com. Then in response, what we are getting is answers. So we are getting quad 5 and quad 6 both. So I'm matching just quad 5, which is okay. Now in place of that, you could also use like maybe ICMP based monitor. And for now, I would like to keep using ICMP based monitor because in future, if something does not work, I would like to capture my data, and then I would not be able to differentiate these queries made for monitoring or maybe sent by the end users. So let's do one thing for now. I'll keep, all I wanted to show you that we can also use the DNS monitor. But for now, let's keep using gateway ICMP, which is okay now, right? So now it will start pinging those servers, which is fine. Obviously, in production, I would not really go with ICMP. I would keep it DNS based monitor only. Because if I have got DNS servers, then I must monitor if DNS services are running on my backend servers. So anyways, so this pool is created now. And if I go back to this pool properties, okay, let me go back to this pool. So this pool and then advanced settings here. So these are the advanced settings here for this pool. And this is not enough. You need to create a listener. Without creating listener, your DNS would not process any of incoming DNS queries. So remember, your DNS, big IP DNS, will not be processing any DNS queries unless you create a listener. So I'll have to go back to my big IP DNS now, and then delivery and then listeners. So you have to create this listener. But for that, you have to understand, you have to know about IPs. So as I told you, like we have got a public IP pool, which is 7770. So I'll pick quad 7 IP address, quad 7. So create, let's say I got this IP address. So this is my DNS listener, DNS listener 1. And the host IP address is quad 7, by the way. That's a host IP address. And also we could tell that on which VLAN it should listen. So it should be enabled on external VLAN. Then UDP is fine. Then default pool, that is DNS server pool. I could also enable the persistence here. And in place of basic, I could also go to advanced. One thing you would notice here is that if you go to listener, basic, and then advanced here, that source address translation is by default, forget about source address translation. Even destination address translation is disabled, which means, like if you remember on LTM, the moment you hit virtual server, it picks up the pool members from the associated pool, and then it translates destination IP automatically. But you know what? DNS does not do that. And it's not enabled by default. Although I'll go ahead and finish it up. So my listener is created now. This listener is having a pool associated with it, load balancing. So you see that pool is available. So its IP address is quad 7. That should be my DNS server IP for my client PC. If I go back to my client PC now, and if I go to ncpa.cpl, I have to wait until it responds back. This is weird. It's not responding client PC. I have to make sure that, the DNS server IP for this client PC is set to what I have configured as a listener IP. Might have to reboot it. So stop. And then start. So let me open up this ncpa.cpl and then go to properties. Make sure that your DNS server is quad 7, which is already there, which is great. So now I'll do one thing, go to command prompt and say ipconfig, then ipconfig plus all, so that it displays you the DNS server IP as well. So that's quad 7. I'll say ns lookup, and that's my DNS server here. So www.imedita.com. So are we getting any response? So it says no response. And you know what? Let me capture now again on Ethernet 1.2 interface of the BIG-IP. I would like to show you that BIG-IP is doing load balancing, but then let me again send it for www. So you would see that yes, we sent a request, a query here, but we are not getting any reply back. But when you are sending a query, so destination IP address did not change. The source is obviously client public IP address 11.1.2. That's a NAT IP address of the client. But destination is quad 7. Even after traversing big IP, which is insane. None of my Windows server is having that IP address. So none of them would accept that packet. So all you have to do is you go to listener, and then under advanced settings of the listener, say address translation is this, port translation is this, if you have to, and source address translation is none, but you can also do the auto map if you're not using default gateway on your backend DNS servers. So I'm going to use now auto map and then update it. And now I'll capture it again. So I'll stop the capture. We'll go back, start the capture again on 1.2 interface. So last time we saw that destination IP was not translating, but now this is ICMP echo request. But the moment you send a request DNS query, you sent a DNS query, but also you got a response back. You could see that. But this time it's coming from 50.1 because a SNAT took place. And then the destination is 50.20 or 50.10 because destination NAT also took place. So now you could see on this client, I have got these two IP addresses. And that is what I was supposed to receive. And then for it.imedita.com, I got it. Then hr.imedita.com, I got it. So what my DNS is doing is just doing the load balancing. We can also validate that. We can go back to listener and then statistics to see that if it is receiving some packets over here, right? So yes, it is receiving. And go to this listener, statistics, And then probably you could also select if I go back to module statistics, DNS, and then delivery, then pools and nodes. So pools and then statistics. So for this pool, these are the statistics. So you could see that yes, the requests are getting distributed among these two DNS servers, these two pool members. And the default load balancing algorithm is like round robin. So this is what it is following. But my big IP DNS is not providing any response back internally. Like it's not doing anything. What it is doing is if the request DNS query is received on the listener, so obviously the destination IP address of the query should match with this listener's IP address. That is what is happening. The moment it receives the DNS query on this listener, then it will check if I have any pool associated. So yes, it has a pool associated. So it will be picking up the pool member, and then it will forward the DNS query onto that server, and then server will respond back to big IP DNS, and then big IP DNS is responding back to your client. So at this point in time, this big IP DNS is acting as a load balancer. It's not acting as a DNS server itself. Now this task could also be done, or we could have done this task using LTM also. What's make this big IP DNS special then? If we could do the same thing using LTM, then what makes it so special that we use big IP DNS in production environment? So remember that for now, I'm just trying to perform the migration. So I'm just using big IP DNS as a load balancer, but slowly we will migrate our applications from traditional DNS to the big IP DNS using global server load balancing mechanism, GSLB, which is an intelligent feature of big IP DNS. So we don't move all applications from traditional DNS to your big IP DNS in a single shot. We don't do that. So first we introduce big IP DNS as just a normal load balancer, and then keep using your backend or older Windows DNS servers, or maybe whatever you have got info blocks or whatsoever, and then start migrating your applications from traditional DNS to big IP DNS. Remember, the one of the biggest advantage of the big IP DNS is that the volume that it can accommodate when it comes to DNS requests. Like if it receives millions of DNS requests, still it will not go down. It will be able to accommodate the DNS requests coming in. So if there is a DDoS attack happening on your DNS servers, and if you are using Windows DNS server, it will be very difficult for your Windows DNS server to tackle the DDoS attack. But considering big IP DNS, the resources available on the big IP DNS, it is possible to handle that many requests, and then DDoS attack would not really create any panic or any problems or any outages for you if we are using big IP DNS out there. And of course, on top of it, it has got many other features, and we will keep exploring them as we move further. But for now, we are just using this big IP DNS for the purpose of load balancing. That's what we are doing. Right? We have just introduced big IP DNS in between now. Now we could also prove this name resolution process. We could make it faster by enabling caching, by doing the zone transfer. That is what we have to learn in big IP DNS now. And that is what something I will not cover today. I would like to have the other participant, Abu, on the call, because he is also kind of esteemed person to learn this technology. So today I have set it up normally. You have seen that using big IP DNS as a load balancer. You've seen that how big IP DNS is distributing the DNS requests among the pool members. So we learned about the listener that by default, it does not perform any destination NAT. To do so, we had to move under the advanced configuration, and then we had to enable it. Also, I enabled the source address translation by enabling automap. That is also something that I did it, you know. But rest of the things we will learn in next session. Not rest of the, I mean, I will not be able to cover everything during next weekend. It will take 2 more weekends to cover the entire training, this DNS training, because DNS is not that big module. It's a smaller module, and we saw the number of chapters that we need to cover. And based on the content that I displayed you yesterday, I've already covered like first 2 chapters. The third chapter we have already started, and it will be completed as soon as I cover the caching and the zone transfer. Because in third chapter, basically you learn that how to accelerate the DNS resolution. So we can have our big IP DNS to accelerate the DNS resolution by enabling either caching or by implementing zone transfer. And finally, we will start migrating our applications from traditional DNS to the big IP DNS using GSLB. where you would introduce the intelligence of the big IP DNS, because that type of intelligence is not available on your Windows servers or maybe Infoblox or maybe any other like Linux DNS server and all that. So that is it for today. And we'll continue next week then furthermore, and you would enjoy it a lot.